Hello everyone, I am Bhanupriya DA from Sri Venkateshwara College of Engineering from Data Science Department. Today we'll be talking about the topic NFA to DFA conversion. In this presentation, we'll learn about essential concepts and practical applications of converting a non-deterministic finite automata to a deterministic finite automata. In this, we'll explore many core concepts, constructions, methods, and real-world examples of this significance process in theoretical computer science. Why convert NFA to DFA? Why actually there is a need of conversion from NFA to DFA? DFAs are more efficient than NFA for processing strings. This efficiency stems from their deterministic nature, allowing for simpler and faster execution. Compared to NFA, DFA can be executed fast. Coming to practicality, in real world applications of automata theory, often we require deterministic behavior. Like DFAs will provide a reliable and predictable framework for all these applications. Let us first know what is NFA and DFA. NFA is a non-deterministic finite automata. This can have multiple transitions from a single state. From one state, you can have different transitions to different states. It allows for ambiguous paths during string processing. Coming to DFA, DFA is a deterministic finite automata which has single transition for each state and input symbol. Here the transition is only for each state and has different input symbol. This deterministic nature makes it unambiguous and it is efficient for string recognition. Okay, how do you build an DFA? First, you need to identify all the subsets of the NFA states. Then you define a new DFA state for each subset. Whatever subsets you have got from NFA states, you need to define a new DFA state from each substate. Then you'll define each DFA transitions based on the NFA transition. You need to check whether if one subset string matches the other and the DFA transition is based on the NFA transition. In this DFA, we use Hopcroft algorithm. In this algorithm, we mainly concentrate on three aspects, that is partitioning and refinement and minimization. What is partitioning? First, you need to divide the DFA states into equivalence class based on their behavior. First, to convert it from NFA state, you need to divide the both the states like DFA states into two equal classes. Then you need to refine these partitions by iteratively identifying states that should belong to different class. For example, now this remains one you if you take this DFA state and you need to divide this into two states, and in these two states you need to identify which state belongs to which class. Both the classes are different classes. Coming to minimization, the final partitions represent the minimized value. In this minimization, after you divide and then you refine, then you will have this final partitions. Okay, how do you calculate the subset construction? First, you see the start state. The start state is the closure of the NFA start state. As you can see in this image, the DFA start state is the closure of NFA. Then transition functions. For each DFA function or state, you need to define transitions based on NFA transactions. Like for each input symbols, you need to give different states. Coming to the final state, The DFA final states are those that contains the state which is in the final state. As you can see here, NFA first it is transition state from NFA to DFA. Then it comes from DFA. From each DFA you will divide it, like you will define the transition based on these symbols, and you get the final DFA state. How do you handle this empty inputs? Calculate the epsilon closure for each state, including all reachable state via epsilon transitions. While writing transitions, you will have to majorly concentrate on this epsilon transitions. If you have any empty sets or any empty inputs in your DFA or NFA, conversion from DFA to NFA or NFA to DFA, if there are handling any empty inputs, then you need to add on this epsilon closure. So this helps in, like, it includes all the reachable states via epsilon. This transition updates can be like this. You can update this DFA transition based on the epsilon state. Non-deterministic in DFA, choosing paths, like how first you need to choose the input symbol and power set state and determinism, and a DFA transition to this state resolving the non-determinism. Consider, for example, consider an input symbol and all the possible transitions from the current state. Then you create a new DFA state that encompasses all reachable states. There are many practical applications when you convert, like when it comes to NFA to DFA conversion. Lexical analysis, parsing, and coding generation in compilers actually rely on DFA basic techniques. Network protocols like TCP/IP use DFAs for packet processing and error detection. And many text editors utilize this DFA conversion for matching their features and highlighting some contents. So NFA to DFA conversion simplifies automata for efficient computation. PowerSet construction is a foundational method for DFA creation. Hopcraft algorithm optimizes DFAs for increased efficiency. Real world applications demonstrate the practical significance of this process. Thank you.